Today we're starting a unit on different topics in geometry. For today's topic, we're going to talk about the midpoint and distance formulas. We're going to start with the midpoint formula. Now, if you're trying to find the coordinates of the midpoint, the way that you do this is by using this formula, which finds the averages of the x-coordinates and of the y-coordinates of the endpoints. So say that you had 2 points, x1, y1, and x2, y2. The midpoint of those 2 points is given by the following. So M, standing for the midpoint, has 2 coordinates, an x and a y coordinate, where the x coordinate is x1 plus x2 over 2, and the y coordinate is y1 plus y2 over 2. Let's take a look at example 1. The endpoints of RS are R, 1, negative 3, and S, 4, 2. Find the coordinates of the midpoint M. So let's go ahead and apply that midpoint formula. Now, if it helps you, you can absolutely label x1, y1, and x2, y2. So x1 plus x2 over 2, so 1 plus 4 over 2. And then y1 plus y2 over 2, so negative 3 plus 2 over 2. Simplifying this, we get 5 halves and negative 1 half. Or if you want to work with decimals, that's fine too. That would be 2.5 and negative 0.5. All right, let's take a look at example 2. The midpoint of JK is 2, 1. One endpoint is J, 1, 4. Find the coordinates of endpoint K. Now for this one, we're going to work backwards a little bit. So because we know the midpoint formula, we can say that x1 plus x2 over 2 and y1 plus y2 over 2 gives us 2, 1. Now let's fill in what we know. We know one of the x-coordinates is 1 and one of the y-coordinates is 4. Now for the other endpoint k, we just label those x and y. And we know this whole thing is going to give us 2 and 1. Now what we're going to do is we're going to separately solve for x and y. So you'll notice here that the first coordinate, the x-coordinate, we have given by 1 plus x over 2, and that should give us 2. So I'm going to set those equal to each other. So 1 plus x over 2 equals 2, and I can do the same thing with the y-coordinate. 4 plus y over 2 gives us 1. Now for each of these, we'll solve for x. So multiply both sides by 2, and then this cancels out. We are left with 1 plus x equals 4 over here, giving us x equals 3. And then for the other one, we have 4 plus y equals 2. And subtract 4 from both sides, we get y equals negative 2. So we get 3, negative 2 for our coordinates of k. Now in this particular case, you could have absolutely looked at what you had there in the graph and found that the x and y coordinates are 3 and negative 2. You're not always going to be given a visual, but here I gave you a visual so you could understand what it is we're actually finding, what information you were actually given. All right, now let's talk about the distance formula. All right, so the distance formula, which is the distance between 2 points x1, y1 and x2, y2, is given by this formula. So d is the distance, is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And this is actually coming from the Pythagorean theorem. Take a look at example 3. We have 1, negative 3 and 2, 4, and we want to find the distance between those 2 points. So I'm going to start by labeling those x1, y1 and x2, y2. Now I'll use the distance formula. So this will be x2 minus x1 squared, so 2 minus 1 squared, plus y2 minus y1 squared, so 4 minus negative 3 squared. Now we'll take care of each of those parentheses, so 2 minus 1 is 1, square that, we get 1. 4 minus negative 3 is 7, square that, we get 49. Add those together, we get the square root of 50. Square root of 50, if we wanted to get an approximation, would be about 7.07. So the distance between points A and B is about 7.